The Space Foundation maintains a strong partnership with the Hosted Payload Alliance, and we are delighted again to have the HPA organize a panel on the topic of hosted payloads. Leading today's panel, which will also feature top leaders from Washington, is Ms. Janet Nickloy, the chairman of the Hosted Payload Alliance and the director of Aerospace Mission Solutions for Harris Corporation. Ms. Nickloy, we look forward to this panel.
Thank you. Good afternoon. Welcome to the last session of the day, but I guarantee you it will be dynamic and you'll enjoy it to take you into the next phase of the evening, which is merriment for all. So let me first introduce our esteemed guests today. We have 4 people on our panel. First of all, General Whelan, to my far right, is the Director of Requirements, Headquarters Air Force Space Command here at Peterson Air Force Base. He's responsible for defining the future of space and cyberspace systems through requirements definition, mission area architecting, and science and technology in support of the Joint Warfighter, Department of Defense, civil and national users. Previously, he served as the Director of Operations and Nuclear Support Directorate, Defense Threat Reduction Agency at Fort Belvoir. He also served as the Deputy Director of Operations, Global Operations Director at U.S. Strategic Command, and was Vice Commander at the 460th Space Wing at Buckley. So thank you.
Thank you.
Steve Kaufman, to my direct right, is the partner with Hogan Lovells law firm and practices out of Washington, D.C. His experience includes serving as lead outside counsel for a satellite company in 15 public and private equity and debt financing, assisting customers in satellite equipment procurements, including hosted payloads, and serving as merger and acquisitions counsel for major satellite companies. So on our panel today, he is representing industry. We're pleased to have you, Steve. Thank you.
Thank you.
So I will now move to my guest in Washington, D.C. And they weren't able to join us here in person due to the S word. But we're so pleased that they chose to spend this time with us this evening. And I know we're making it a late day for you, so I appreciate you spending a little extra time. So first of all, Mr. Loverro, who is on the left, is the Deputy Assistant Secretary of Defense for Space Policy in the Office of the Undersecretary of Defense. And I believe you've been in that role for about a month, correct?
More like 2 weeks.
Okay, so therefore he's definitely an expert. So previously he served as the Executive Director, Space and Missile Systems Center at Air Force Base Command at Los Angeles Air Force Base. And in that role, he was the Senior Civilian Executive and Principal Assistant to the Commander. His responsibilities included Air Force research, design, development, and acquisition of space launch, command and control, and satellite systems. In 2002, he was selected by the Undersecretary of Air Force to lead the Future Imagery Architecture Program. So a very rich history in space, and I thank you very much for being with us. And then finally,
thank you for having us, Janet.
Mr. Chuck Beams, a member of the Senior Executive Service, is the Principal Director for Space and Intelligence to the Undersecretary of Defense for Acquisition, Technology, and Logistics, where he is responsible for acquisition oversight for all space-based and national intelligence programs executed by the Department of Defense. Before his current assignment, he was Director, Intelligence, Surveillance, and Reconnaissance Systems in the Space and Intelligence Office. Prior to OSD, he served as Chief, Operational Capabilities Division, United States Strategic Command, Center for Combating Weapons of Mass Destruction. So, thank you. So you can see from our 4 panel members, we have policy, we have acquisition, we have operations, and we have industry. So I'm looking forward to a very robust discussion today. And with that, we'll go ahead and get started with our first question. So first of all, for the purpose of the discussions today, we're defining hosted payloads as government payloads hosted on commercial satellites. There's always that question is, what is hosted payloads? But for today, that will be our definition. So our first question, what role do you see hosted payloads playing in the future, particularly in light of our budgetary challenges? And Chuck, can you take a stab at that?
Sure, I'd be happy to. First, Janet, thank you very much. I want to thank the Space Foundation for obviously putting the whole symposium together, and especially Harris in particular for setting up this whole VTC capability. It's great to be able to participate. Doug and I both wish we were out there and enjoying everything, but it's great to participate in the way that we're able to. Specifically, the question about what roles do we see where hosted payloads could be useful. Different ways to look at that. One is you could kind of look at it in near term, midterm, long term. I think in the near term, there are there's the obvious one is resiliency, and I think General Shelton has talked about that in some measure in other forums. But another role that I can see is to get towards doing technology demonstrations, competitive prototyping activities, and using the hosted payload as a way to do that in a less expensive way, as a guide towards future architectures, which again will have even more resiliency. The mission areas themselves that could be served with by this purpose really are a lot. The obvious one is COM, right? Commercial satellite communications, but as many folks are aware of, the CHIRP program that Doug actually was sort of the big force behind out at SMC show that we can do that kind of mission. We can begin to look at doing other missions, including missile defense, and I can also envision an SSA type role to do that. So in my mind, the other part of your question was about the budgetary challenges associated with that, and that's why I think that really we have to prove that this is not just a flavor of the month idea, but it's that its time has come, and we'll need to show that through affordability and budgetary sort of analysis to show that not only do we get resiliency, but we actually are able to do things in a much more cost-effective way. So that's sort of how I see it in the near term, resiliency, and then leading to some competitive prototyping activities to a much bigger future where we have netted together multiple architectures.
Chuck, Janet, can I jump in after Chuck here?
Absolutely.
Okay. I think Chuck has definitely hit some of the high points in the things we can do. But I really do believe that in this regard for hosted payload, the skies, or more specifically, space is the limit. The sky is the limit here. Hosted payloads fundamentally change the dynamics with how we view how we get things to space. Frankly, it all used to be about how do we build a satellite and how do we go ahead and get it on a launch vehicle. With a hosted payload, that dynamic changes. It's now how do we put capability on what already is waterfront property that will be there in the future. So it starts to ask us to think differently about how we view getting mission capability to space. It's not just a engineering trick. It's not just a business trick. It causes us to go ahead and look at how do we view this differently. You've seen this in some of the weather work that's going on in low altitude. We talk about hosted payloads a lot in high altitude and low altitude. We have successfully done with other governments as well as with industry looking at several ideas for how we could host weather sensors on other spacecraft that will already be up in low altitude orbit, and obviously the OPIR stuff that Chuck talked about in high altitude orbit. So as we talk about what roles will hosted payloads play, I think we can look across the entire panoply of roles that space has. There isn't something specific that hosted payloads can or cannot do. I think they can do just about anything we want to. What we really need to do is talk about how do we want to use this new tool differently. And I think that's going to lead to some great ideas as we move along.
Okay. All right. Thank you. Anything else you'd like to add?
Let's go to the next question.
Okay. All right. So let's. This is a related question, actually. So what missions do we view as well suited for hosted payloads, and which missions do we view as unlikely? General, if you could take a shot at that, please.
Yeah, Chuck kind of laid out a couple of the mission areas, and I think I would tell you specifically areas that we're looking at for hosted payloads include weather, whether it's space weather or space-based weather of the Earth, are two real near-term areas we're looking at. We're currently doing an analysis of alternatives of space-based weather, and really in the play is not only microsatellites and free flyers, but also hosted payloads, and that's a near-term opportunity that we're really looking forward to working. But also OPIR. Chuck mentioned the chirp work that SMC and Doug spend a lot of hours on, probably more like months, but we'll just keep it at hours. But as we're looking at disaggregating our architectures, one of the lead areas we're looking at is in the overhead persistent IR area, and believe that there will be a combination of hosted payloads with dedicated satellites in that area as well in the architecture. Space situational awareness that Chuck talked about, and this is one that I think is more than a hosted payload opportunity. It's an opportunity for everybody to contribute. And if we put sensors on not only commercial satellites, but government satellites, be they military or civil, that gave you a close proximity understanding of your near neighborhood. If you stitch all that together, you get an understanding of the situation and that orbital regime. So we're really pushing not only hosted payloads, but payloads that we can expand our own satellites to enhance our space situational awareness. I did focus on military. I know your definition was, government payloads. I don't feel myself an expert to talk for NRO or NASA or NOAA, so the examples I gave were there. But on the flip side, what's unlikely? My sense, and this is where Doug and I may have a little difference. I think the sky's the limit, but we want to take our climb to the limit in a couple of steps. An area I don't think that we'd be looking at hosting in the near term is things like the nuclear detection capabilities, treaty monitoring capabilities. There's a lot of international dialogue that happens based on data that comes in those areas, and I think trust of data and being able to keep that data in a box is going to be important early on. Now, if we learn as we go forward to trust data in the hosted payload realm, we'll get there. But I don't think tomorrow. We'd spend more time trying to do the discussion and the convincing and less time actually working on the hosting issue. And so I think I would stay away from those areas in the near term.
Okay. All right. Anybody else want to add to that?
I think you covered it.
Okay. So let's talk about policy a little bit. So what policy issues inhibit government considerations of commercially leveraged solutions such as hosted payloads, and what steps can be taken to address these? So, Mr. Policy. I take it
you want me to answer that one, Jen.
Well, you're the expert, Doug.
Let me say, first of all, there aren't any specific policy issues that talk directly to hosted payloads, as a potent activity for government. There are clearly policies that we have out there that guide how we can go ahead and approach hosted payloads. Some of those policies are acquisition policies, obviously, and working through how we acquire, how we pay for, how we contract for hosted payloads isn't so much a policy issue in the big sense. It's more of a how do we apply the tools and the flexibilities that the FAR gives us to go ahead and acquire these payloads. The other side of the issue is what happens on the policy side when you run into situations where you may be hosting something very sensitive on a foreign procured, foreign owned, foreign supplied, foreign launched vehicle. Again, no prohibition per se, certainly some trepidation. And it's those trepidations that we need to go ahead and spell out, understand what steps we all want to take in order to go ahead and guard against unintended consequences. You know, Marty, I think, correctly said, and I didn't mean to suggest that we would put a nuclear missile warning capability on a commercial satellite. That really isn't because we can't, it's because we just wouldn't want to do it. It isn't prohibited by policy. Certainly, our policy would guide us in a way that would say, you know, that's probably something we want to keep on the military side of the equation. So we have, for example, many people have said, well, our launch policies allow us to launch those payloads that are on commercial satellites on a foreign launch vehicle. As you know, the CHIRP payload was on a spacecraft that was launched on a French vehicle. I always thought it was kind of interesting. It was on a Dutch-owned company's spacecraft flown from the launch base on a Russian aircraft to a French launch base to be launched on an Ariane rocket. So a really international collaboration to get that payload to space. And we worked through those issues. We are right now looking at how might we adjust policy to make that easier. But even under today's existing policy, that would not be restricted. Folks have asked me, well, would we ever do that on a Soyuz rocket or on a Russian-owned rocket or perhaps even on a Chinese-owned rocket? I think that would cause us to pause to think about. I think we have to figure out how do we work through it. But again, there isn't a prescriptive policy that prohibits us from thinking about any of those kind of things. Many of you are familiar with, and I think we're going to have a question later on some of the spectrum issues that might tend to hosted payloads. Again, these spectrum issues they're not just a DoD spectrum issue, they're international spectrum issues, and we have to go ahead and follow all the rules for how we use spectrum. But again, I don't find any policy that specifically inhibits us from going ahead and doing anything we talk about doing. We certainly could go ahead and change policy to make it easier, both on the acquisition side, from a tech perspective, and on the launch spectrum side, from my perspective, CIO's perspective. You can certainly adjust some policy to perhaps make it easier. But I don't think there's anything out there right now that prescribes how we, or says we could not do a hosted payload for what we wanted to do.
Okay. Very good. Anybody else want to add to that?
Policy man has spoken.
I guess I agree with Doug. It's just the hard part is doing it.
Yeah.
And I think we're going to talk about that a little bit in the how do we change the culture, because I agree with them wholeheartedly, and there hasn't been policies restricting it. Yet we can name the couple of successes we've had.
Exactly.
So there's a barrier. We got to identify and work through the barrier.
For some reason, it's still not easy. So we need to dissect that a little bit more. So okay, so I think we'll probably dig down that as we progress down the questions. But let's talk about terms and conditions a little bit. So sometimes, many people here have a technical background. Engineering does not tend to be the challenge associated with hosted payloads. It's really more the business side, which gets embraced in terms and conditions. So Steve, can you comment a little bit on what T's and C's tend to be a challenge and what are potential solutions?
Sure, absolutely. I would say number one, picking up on what some of the other panelists have said, probably is control. When your payload is being hosted, the amount of control you have over your program, over your technology, over what happens to your data is significantly less than if it's your own program. And so compromises have to be made. There are some engineering workarounds that can be done to try to enhance the level of control that you have over the program. But the analogy might be given to, instead of chartering your own plane, you're taking a commercial aircraft, and it has its own schedule and its own limitations. Costs a lot less, but you have to go with what is available, and that's a big change for some critical technologies or highly important data satellites. So that's probably, I would say, the number one. Number two is people have to face up to the fact that when you're sharing a bus and sharing limited resources, you get into operational priority questions. And having negotiated and worked on hosted payload contracts, one of the big issues is if something goes wrong on the satellite, whose payload has the operational priority? If there's limited power, if there's interference, if there's design issues, does your hosted payload get turned off and that's the end of your mission, or does your power get cut down, or is it preserved for your benefit and the satellite owner or the main payload, if you want to call it that, has to make accommodation? It becomes a dollars and cents question, and you may have to pay for the priority, but certainly working through the priority issue is one of the big issues of coming to terms with the fact that there's a shared resource and not a controlled resource. Number three, and a big one for a lot of folks, is timing. The aircraft analogy, you're on a program that already has a stated schedule. It's a very rapid schedule. It's moving. You don't have the time you need to, if you want to be on that program, you have to go with it. And one of the solutions we'll talk about as we get down to the program is, to a large extent, you have to think about in advance whether you're going to be hosting and what your options are, and start early. If there's a one-of-a-kind program like an Iridium and it's already on a schedule, there isn't much you can do about it. But in a lot of cases, you're looking to host on whatever convenient satellite is there, and you know that some of these satellites are going to be replaced in 4, 5, 6 years. If you start that discussion early, you will have the time you need to work into the schedule. And if your payload is late and the schedule slips, there's room in there. If you're already up against it when you start your program and there isn't enough time, it makes it very difficult to manage that risk. And then finally, I'd say financial is a big one. You know, one of the benefits, and there are very large benefits to hosting in the financial area, a lot of savings. How do you really realize on those savings? The more you need control, the more you need priority, the more you need, you know, the ability to control the timing, perhaps the less the savings you're going to enjoy unless you can start early. And there's a negotiation that goes on. These are all custom projects to some extent. The savings are clear, who gets them, how they're divided up, and then what contingencies is something that needs to be negotiated, and there's no template for this. There not only isn't one in the GSA schedule, there isn't even one on the commercial side, because these are custom projects, and that involves a bunch of new things that you usually don't factor in your program, having to negotiate how the savings are shared. So I would say those are my big four. There are plenty others, but those are the big ones.
So any comment on that? Go ahead, Chuck.
Jan, I've got something to add on to that one from an acquisition perspective.
Absolutely.
I completely agree with everything that Steve said, and I guess what I would add to it is that a challenge from an acquisition perspective is that we typically acquire things to meet requirements. And one of the big challenges that we see going into the future as we get and making these capabilities operational is exactly the intersection of what Marty and all his guys are responsible for with actually meeting that with some high degree of confidence, because that becomes ultimately our measure of merit. And so we need to figure out how to intersect, because as you said, the engineering part of this, especially for some of the less complicated ones, it's actually not that difficult. Challenge is, there are some policy challenges, but I agree with Doug, those are somewhat minimal. The challenge is the requirements, the way our system is set up, they get vetted, they go all the way up to JROC and all that kind of thing. And then a program is put in place to meet that requirement. Well, when we're trying to intersect that acquisition, meeting those requirements, it's not cut dry. And so what we're going to have to do as we go forward into, I'd say, the mid and longer term, figure out how to crack the code on that. And that's not it's not as difficult to do. Prototyping is competitive, and I'm a huge advocate of that. But when we become, or we want to rely upon that for deliver an operational capability to the warfighter, that'll be a challenge. Quantifying that is going to be a challenge.
Janet, let me add on to something that Chuck said that reminded me of something I wanted to say during the panel. So the first that you hear from Chuck that I think is spot on is we really need to learn how to do this in a prototyping fashion as we move towards operational payloads. And I think some of the work that with the IDIQ work, and as Marty said, in looking at whether just give us an opportunity to go ahead and approach this more slowly. But I want to applaud an activity that happened about a month ago that goes also to the question about how do you deal with operational priority and what kind of conditions do you need. Many of you know, not advertised several months ago, an issue on orbit with the Chirp payload. We hadn't written the contractual language about how to deal with that. Who has priority? How do we work? But I got to tell you, I was incredibly impressed by the cooperative nature of SES Americom and Orbital Science, SAIC, and the government in working through what could have been an issue where we all held up our contract and said, sorry, we're not going to do that. And instead, we worked incredibly cooperative engagement and recovered the payload up and operating great for us. All partners had to do a little bit of shifting in their seats in order to get us there, but it was a great example of how on these prototype things allows us to figure out here are the kind of issues we're going to face. Here's a model of how we work through them. And so again, I want to thank everybody who was involved, that all the way down to the Payload Alliance and across the industry, because I think it gave us a fantastic example of how we can go ahead and very thorny issues, which Steve articulated, they don't have to become lose-lose situations. They can become win-win situations.
Absolutely.
Excellent point.
Absolutely. That's great commentary. And let me just add from my role as chair of the Hosted Payload Alliance, certainly in the discussions that I've had with my industry colleagues, we're looking for win-wins. And there is 100% motivation to make hosted payloads successful. I think everybody recognizes that certainly we can have all the planning in place that we need. We can take the necessary steps. We can follow our collective deep legacy in successful space missions. But sometimes you can't predict the unpredictable, and there are issues. But everyone's going to rally together and try to work through. And typically there's a solution out there. So it's great to hear that story, Doug, of just a very recent example of industry and government coming together, even to work through the unexpected. So, and I suspect that that's just it's a picture of the future. So, thank you. Anything else on that comment? All right. I think we got time for maybe one or two more before we head into questions from the audience. So let's just talk a little bit about culture. So hosted payloads are certainly a change in government practice. So when we think about culture, what issues are inhibitors to hosted payloads, and do we see progress on this front? So General Whelan, if you could please respond.
Well, I guess I'll kind of say, I think Doug hit it, and we talked about it earlier. I don't know that it's I coin it this way, it's not an electrical engineering problem, it's a social engineering problem. Getting people to think differently. Mm-hmm. And I don't see a large group of people who are vehemently protesting hosted payloads. Mm-hmm. But there's a silent momentum that has got to be changed so that we can think a little bit more broadly on hosted payloads. So it is an engineering issue, but not the kind that we're really good at handling. Mm-hmm. And so it's going to take some work to do that. The other thing is it's tied to control. And I appreciate, Steve, that you raised that, but the control from the programmatic standpoint is from program managers. From the time we raise them, we teach them not to rely on anybody else. The success of your program is on you, and you've got to succeed. And that may be a bit of an overstatement, but that's certainly an underlying theme. And so we got to get people to realize that they're part of a bigger success. And so that's a part of the change in culture that we have to work on as well. Timelines. Government timelines and commercial timelines don't seem to be the same. And the reason I use that term is I'm not a commercial guy, so I can't speak eloquently from the commercial side. But I know our government timelines, our CEO and our board of directors and all the people that we have to answer to on risk statements tend to be on the news a lot more than maybe your CEOs are. And the debates are done a lot more publicly than yours are. And so that creates a little bit of angst and a need for understanding. And so we do take longer to make those decisions so that we can answer the questions to the people who are doing their due diligence to look after taxpayer dollars. And so I think that's a big part of the culture. But are we making progress? Yes. We're talking about it. There are some successes, as Doug mentioned, and things like the HOPS IDIQ is a step in the right direction. I'm not sure it's sufficient, but it's going to take a lot of steps to get where we need to go.
Can I take a follow-up on that? I'll say that the cultural issues associated with hosted payloads are not unique to the military. In industry, it's a different beast, and people have to accommodate this in a lot of ways. Control is a big issue in industry. Timing is a big issue in industry, and we try with enough advance notice to work these issues. Some level of control can be planned for. There are some engineering solutions where you can have greater control over your payload than would ordinarily be the case, but that needs to be designed into the satellite, so you need to start early. Timing, the longer schedule that government and some commercial programs need can be accommodated, but again, you have to start early and you have to find a host who has room in their schedule to really allow you to do things, plan in advance. Plus, when you get to the actual decisions while the payload is being built, we have worked into contracts that instead of 30 days to make a decision or 60 days to make a decision, you have a longer period of time, you have more data, but that needs to be worked into the schedule up front. You can't decide midstream that you need more time. The train is leaving the station and you're on it and you're going to have to go with it. And then from an operational perspective, again, there are things you can work in. It is a partnership. Is a partnership in building a satellite and payload. It's a partnership operationally over the life of the satellite, and you have to work that into your relationship. Part of it shows up in your agreement, and your lawyer can help you with that. But part of it is just establishing a relationship with a company, as Doug was talking about, where you know you're going to do the right thing, whether it's written in the agreement or it's not written in the agreement, and a way of handling issues on a relationship basis. This is a relationship that's put in place for an entire term, and people need to accept that at a cultural level.
I have one thing to just add to that from a cultural perspective, if I could. General Whelan's actually being pretty modest. Another aspect of the culture and how do you change it begins with the seeds that you plant early on. And I can tell you that the AOA that he mentioned up front on weather, and principally his team that is actually doing that analysis, they are looking at hosted payloads on an equal footing with all the other alternatives, and that's a huge step, because now we're getting to what I was talking about before, that midterm and long term. We can begin to look at what does it really mean to rely on something operationally from a hosted perspective. So, I mean, from OSB's perspective, hats off to the Air Force Space Command for really showing true leadership in that area.
All right, thank you. Okay, so I have a question here from the audience that I'll give to the panel. What is the difference between a hosted payload and a hosted mission? Would it not be more efficient to host a DoD mission in the development of commercial satellites rather than paste the mission on the commercial satellite parasitically?
Well, I'll take a cut at that. Okay. We tried to take an enterprise look at our mission areas. And in the introduction, you say, I did mission area architecture, and everybody says, what is that? The mission is is to deliver whatever we have. In the case of weather, I can talk to that being off the top of the AOA, is to deliver the data and the quality of data and the timeliness of data to the user, the consumer, in a timely manner. And so there's lots of ways to do that. A hosted payload is one way. I don't know I'd call it a hosted mission, because I may need a combination of free flyers. I may need a combination, or a combination include free flyers, hosted payloads, buying services from international or commercial partners that I don't own. I just buy the data. And so to accomplish the mission, it's not simply a hosted mission, it is part of an overall architecture. And I can use the same examples in protected communications or in OPIR, all areas. It's what my dad taught me when I was little, the right tool for the right job.
Right, right. Good. Okay. Anything from DC? Go ahead, Doug.
The policy
I'd like
guy
to
wants
add
to
on to
talk.
what Marty said, because I agree with him 100% again. I mean, and weather is a perfect example of doing this. You know, if you're one of the weather guys on the end of the stick where you're receiving this weather data, you actually, in most cases, have no clue where the data is coming from. It's coming from, as Marty said, foreign satellites, NOAA satellites, USAF satellites. Some of them are coming from ground stations. And all that data is getting mashed together. In fact, at a symposium several months ago, General Shelton remarked how really, as we think about hosted payloads, as we think about disaggregation, and these two concepts really overlap when we get this question that you're asking, it really becomes, how do we go ahead and handle the data? How do we bring it together on the ground? How do we engineer that new data pipe? It used to be, we were all very comfortable with saying, here's my requirement, let me design a purpose-built system that meets every one of those requirements. And with hosted payloads as a portion of most answers to requirements, you have to say, I'm going to allocate each part of the requirements to that hosted payload, this to a purpose-built satellite, this to an allied satellite, this one I can already get through other means. That becomes a harder challenge. Going back again to the cultural issue, you don't like to think like that. It's hard. It requires different kinds of system engineering skills than the system engineering skills we typically teach. And yet we can recognize the huge benefit by going there. And so I think, as Chuck said, Marty and his team are leading the way on the weather side of this. I think you'll see us bring the same kind of thinking to bear on our protected comm studies and future AOAs that we'll do. But it is harder to do, because when we look at that full mission, which is what the question was about, it becomes more than just about the payload. It becomes, how do you bring all that data and services together to create that mission need?
Yeah, and if you don't allocate it to just one, and say this is allocated to hosted, but if you disaggregate the requirement, I build in resiliency. So I lose my hosted payload, or something happens on orbit and that the host itself has a problem. I don't lose everything. And so we have to find a cost-effective way. There, Chuck, I said that. A cost-effective way to achieve those requirements.
So there's a few questions about what can industry do, because it's certainly, you step back and look at the mission from this broader view of it's really fitting into a larger context. It involves industry, not only just for flying a payload, but also aggregating the data on the ground, and certainly from a planning standpoint, you need access to more information than perhaps that you've had to have access to in the past when you were in full control. So what can industry do to help in the planning and preparation process to leverage hosted payloads?
Well, since I'm here representing industry, let me take a first shot at that. I think in general, a lot of planning can be done by industry to accommodate hosted payloads, whether they're government or the commercial. As it gets to be more and more common, you're going to start working with the satellite design so that the hosted payload can really fit into the program when it's already in process. You're already planning for it. It doesn't require such a major system redesign, lowers the cost. Plus getting to the timing element, if the government needs to make up some time, or whoever's owning the hosted payload needs to make up some time, if you've already built that element of the program into it, I think you're much more able to accommodate that. To accommodate the control, that's not always so easy, but as I say, there are some engineering solutions where you can have direct control as just the hosted payload owner of certain things that you really need control over that don't route through the satellite. That's not the typical design. Often the satellite owner controls not only the hosted payload power, but the data, but there are overrides that you can build in if you really need to. They cost money, they take time, but it's something that can be worked. Working with government budget cycles is another one. We have represented some governments, foreign governments in procuring satellites, and we consider that industry commercial. But governments of every kind have particular requirements, and they need more time. They have decision processes that they need to follow. That can be baked in to the overall program. It needs to be planned for, it needs to be put in the documents, but it can be accommodated. One of the things that we do, for example, you've got a satellite's got a 15-year life. Governments can't have typically 15-year budget, open. You have to buy your payload, you have to pay what's owed, and be done. You can't go back every year to pay a fee or to cover costs. And so industry can accommodate this by making sure that whatever monies are due are paid when the satellite goes up, and then there are no more obligations for the government to keep paying. And of course, if there are performance requirements, that can be done as what we call a payback. If things don't work as expected, you can get a refund, but that doesn't have the same budgetary problem and budgetary cycle. You're done, and you don't have to worry about the budgetary overhang. Those are three that we've worked with on a relatively frequent basis. I'm sure there are plenty of others, but I think in general, as hosted payloads become more frequent, these solutions will become more readily apparent and more easily accessed.
Okay. Other comments on how industry can support?
I'll just throw a couple, and I haven't come up with a checklist per se, but ID, identify, swap, that is available, and opportunities, timelines,
Sure.
Target dates, things like that. And I think the hosted payload IDIQ is opening the door to that. So it's going to be helpful to us as industry identifies opportunities. And for fear of getting in trouble with half the room and pleasing half the room, standard interfaces. Standard interfaces have a real upside. They also have a downside, but many of our standards in society have been driven by industry. As industry has become a leader in technology, and as standard interfaces, either one or some or family of interfaces, would become very helpful, because then those opportunities become easier to take advantage of.
Absolutely. Doug, Chuck, anything?
The only thing I would add is getting back to the cultural issue. Changes in culture require, among other things, a lot of persistence. So I guess getting back to bringing ideas, that kind of thing, be persistent and relentless in pursuing these business opportunities, because they're there, and don't get discouraged if one initiative seems to not work or something like that. Just stay persistent.
I agree with Chuck on that. I mean, I think we all are very excited about the potential that hosted payloads hold for us, because of the resilience they give us, as Marty's already articulated, because of the budgetary improvements that we can see from them. But it is going to take us some time to get our feet under us, and I am very hopeful that industry doesn't give up on us, in another year or so and say, well, they'll never get there, because it's going to take a concerted effort from those of us on the government side who believe this is a part of the future, and those of you on the commercial industry side who believe it's part of our future, to push together on this ship. Otherwise, if we only have one of us pushing and the other isn't there, it's going to become that much harder to get there.
Excuse me. Okay, very good. So with respect to disaggregation, do we really expect we will have no reduction in capability? We have different satellites sensing different spectrums.
I'm sorry, I kind of missed that.
Sure. So the concept behind disaggregation, it's a new way of looking at the mission. And so when you think about having different sensors on different satellites sensing perhaps different frequencies, do we think that we're going to have reduction in capability, or can we still accomplish the mission?
I think you can accomplish the mission. It's how you architect, and you hit it on the right point in the question. So whoever put it there, it's about the capability. It's not about the sensor. When you architect, the sensor helps fill part of that envelope you're trying to accomplish. And so in some cases, if you pick a certain sensor, you might need to match it up with a similar sensor that can be integrated with it. So it's not about throwing up a hosted payload to check the block that says you have a hosted payload and does a little something, but it doesn't add to the mission. And I'm talking from an operational standpoint. I'll leave a little room because Chuck opened the door for hosted payloads for prototypes and tech development and stuff like that. That's where you can take those kind of risks. But when you get into an operational enterprise look at these, you put your capability on the table, and then you try to see what contribution each of those different elements bring forward. And as long as you can cover the full gap, or at least the majority of the gap in your combination, then you're able to take the enterprise approach to it. But it's about delivering the capability, whether it's one sensor or 15 sensors. Yep. And then cost will drive the smartest way to do that.
Yeah. Agree.
It kind of goes back to Chuck's comment earlier about really taking a full systems engineering view of the problem and looking at it holistically. So certainly a new additional set of skills that's required on your part. Excuse me.
If I could, Janet, I do have something to add to that as well. For a second, I'll talk about the stepchild of our business, which is the ground. I think that to get to General Whelan's point about capability and then sort of an enterprise look, when we look at disaggregated architectures, personal opinion, I think one of the biggest challenges we're going to have is how we integrate ground processing. I think it is the future. It's the way we're going to go for a lot of reasons. I think not only because of an affordability, but I think that by having a disaggregated approach, we will be able to see things that we weren't able to see before in terms of data and everything else. But the challenge will be giving due diligence, due attention to the ground process, which, again, largely is something that's often an afterthought after focus on the satellite.
Hey, Chuck, I agree. I mean, I refer to that as re-aggregation. Yeah. Because in the end, you need an aggregated answer to your question. So disaggregation in space or disaggregation in the air ultimately takes an aggregator.
Right. Absolutely. I think we're up for the challenge, though, so we'll work through that. There's a question here, and I don't know if we have the answer or not, but how does America stack up to the global market with regard to hosted payloads? Do we see our counterparts being more aggressive on this stance, or are we all kind of learning together?
Let me take a quick stab at that. We have worked with foreign governments, foreign companies. I think the comment was made earlier about how international the space business is, which is very much the case. Lots and lots of different companies, lots of different nations are involved basically in every project. I don't think other countries are more advanced than us in getting used to this. I think a good way to view it is that commercial companies tend to view things one way and governments tend to view them another way. And while we have our own requirements, so do other governments. And They have their own slightly different, but their challenges are a lot more like our government's challenges, and their commercial challenges are a lot more like our commercial challenges. I don't think we're behind. I think the market in general is getting used to and adapting ways of dealing with hosted payloads. And if we start working on this now and it becomes an important part of our repertoire going forward, I think we'll be up with everyone else.
Okay.
Yeah, Janet, if I could add on that, I agree with Steve on this one. I think that this idea of hosted payloads is not an American-born or necessarily owned idea, and yet I think because I think we all have recognized that the time has come for it in many different venues, whether that's in the civil venue, in a commercial venue, in a defense venue. I think that the recognition is large, and again, it goes back to what I said earlier. There's waterfront property being launched into space on a routine basis today in a way that we didn't see in the past. We now have opportunities 20, 30 times a year to host a payload. That wasn't the pace of launch in the 90s. We also didn't know how we could go ahead and disaggregate these capabilities previously. The technology and the understanding wasn't there that we can today. That's not in an American-owned, corner of the world. Other people recognize it. They're ready to take advantage of it, and more power to them. I think that we will all benefit from each other's experiences. We certainly learned from some work that NASA's done on this regard already. The Australians, obviously, with the UHF payload, we've looked at how they've put together their business arrangement. We will see a lot of different ideas being expressed around the world, and I think we will all learn how to do this better.
All right, we're getting down to the last few minutes, so I just wanted to open it up to the panel. If there's something else that you would like to add to the discussion, or if you would like to poke at each other a little bit, I'm perfectly fine with that as well. So,
well, let me take one stab at that and then let everyone else. I think
fight's on.
There you go. One of the things I think we ought to circle back to is, hosted payloads is easy to get taken over by the risk, the change. There are tremendous benefits to doing this on the government side, on the commercial side, for all players. Real cost savings, the ability to access missions that would not, and opportunities that would not otherwise have been available. You have to use the right tool for the right job. It's not for every project, but there are very, very real benefits to doing this. So facing up to some of the changes and some of the risks is something that we really ought to embrace, because there's a big reward to doing it. We're not doing this because we have to. Well, maybe we are to some extent, but we should be doing this because we want to. There are clearly benefits to doing this, and we should have our share of those benefits.
all right.
Yeah, I guess, I was trying to think of something flippant, but I decided I'd better curb myself here. So I think really, as we're talking about the opportunities, one of the things that we're going to have to do, something that, like Doug says, is not uniquely American, we're going to have to accept failure. Something ain't going to work. And that will be the reason we shouldn't pursue hosted payloads. And we've got to get beyond that. I'm not probably the biggest proponent of CHIRP, because it didn't do everything I want, but it wasn't designed to do everything I want either. But I will give CHIRP, the CHIRP program, great credit for advancing where we are. Right. To me, the best thing would be is a plug and play into the Sibbers ground station, and I'd have another sensor. We're not there yet. And so rather than focus on the negative, there's a lot of positive there. And we and the government and you and industry have to help us with that, because most of us are raised to be very discerning, and we really focus on the negative. Right. And we'll do ourselves a big disservice if we do that.
And
totally agree.
I think just to add to that, I think sometimes we do focus on the risk and the inability for the government to have control in the manner they've been used to. But frankly, success is not guaranteed regardless of the mechanism. So we shouldn't we shouldn't assume that we need to, have 100% success on commercial because that's just not the world that we live in. But hopefully we can get to the kind of numbers that we're all comfortable with.
I just blame it all on policy.
There you go.
Chuck or Doug, anything you'd like to add?
Well, since I'm being blamed for it, I guess I should go ahead and add to that. Yeah, I've said, I think, most of this already, but I think it bears repeating. When the department and the president put together national space policy over the last several years, hosted payloads were predominantly featured as part of what we saw as the future, and that wasn't just by happenstance. Hosted payloads provide us an opportunity to meet our resilience needs. They provide us an opportunity to meet our budgetary challenges. They provide us an opportunity, quite frankly, to throw a new level of competition into the provision of space services. And even more than that, I think, and this is the one area that sometimes we forget, hosted payloads provide us the ability to go ahead and do something that wouldn't have been cost-effective to do previously. We couldn't have justified a satellite for this kind of sensor, this kind of capability, this kind of prototype. But with a hosted payload, suddenly we can get over that hump. It has, in a sense, going back to my physics days, it has reduced the activation energy to go ahead and get to a mission. So I think there are these huge benefits that befall us as we move towards hosted payloads. Will it be easy? Absolutely not. Will it require cultural shifts? Absolutely. But I think the gain is so substantial, we can't but go there. Chuck?
I completely agree, and I guess my sort of closing thoughts on this on the panel are that there's never been a time when the stars, literally in the case of General Whelan, General Shelton, General Polakowski, others, are lined up, and then those of us back in Washington, to actually really move the ball forward in this area. There's a lot of us sitting around the table out here in Colorado Springs, out in LA, that have already hit the I believe button and are excited to get on with it, and so I'm very optimistic about the next 5 years. So that's why I think the persistence thing, don't give up, don't get frustrated, or when you do get frustrated, just pick yourself up and keep coming in, talking to us, talking about ideas and challenges and how to overcome those challenges, and we're going to get there.
Awesome. I love those closing remarks. So on such a positive note, again, I thank all of you for participating today, and enjoy the rest of your evening. Thank you.
Thanks back in D.C.